Okay, so this is the video for section 6.3. And in this section, we are going to talk about finding confidence intervals for population proportions. So what a population proportion is, it's the probability of success in a single trial in a binomial experiment. So we denote that by P. The point estimate for P is denoted by something we call P hat. And it looks like it's got like a little, almost like a V, upside down V at the top of it. And so what P hat is, it's going to be the number of successes in your sample divided by the total in that sample. Okay. All right, so let's make a few more notes. Let me move. Okay, so the estimate for your population parameter, we're going to call P, and the sample statistic is P hat. So just like we've been doing before, Q and P are related in the sense that together they add up to 1. So if we know P hat, we can find Q hat. All right, so let's go ahead and kick this off with an example. My cat is trying to help with the notes today. Okay, so we have a survey of 1,000 US adults. Okay, so N equals 1,000. 662 said that it would be acceptable to check their personal email while at work. Okay, so that is giving me P hat. So P hat is success divided by N. So we're going to say 662 divided by 1,000. And that's going to give me 0.662. You can also turn this to a percent if you want, but I usually don't like to do that until the very, very end. Okay, so if I know, oh, that's all I have to do. I don't have to do anything else. All right, so find a point estimate for the population proportion of US adults that say it's acceptable to check their personal email while at work, and you could give me 0.662 or 66.2%. Okay, so let's just write a sentence for that. The point estimate for the population proportion of adults who think it is acceptable to check their personal email at work is 66.2%. Okay, so we can also make our confidence interval using P hat and Q hat. So it's pretty much set up the same way that we've been doing these problems, where we're going to come up with an interval that we find by subtracting our error and adding our error to P hat. And the formula for error is going to be the corresponding z-score that goes with that confidence interval times the square root of P hat Q hat divided by N. All right, so let's just get a little summary here. So first, you're going to identify your sample statistic N and X. Find your P hat using this formula. Verify that the sampling distribution is approximately normal. And you can check this by verifying that N times P hat and N times Q is greater than 5. Find your critical value. So you can use table 4, or remember, you can also use your calculator. So it's whatever personal preference, really. Then you're going to find your margin of error using the formula that we just talked about. E equals your z-score times square root of p hat q hat divided by n. And then you're going to find your interval. All right, so let's kick it off with an example. Okay. So we have 1,000 adults. This is the same example that we were going to do before. We're just going to finish it off. Okay. So 1,000 adults, 662 say it's acceptable to check their personal email at work. We're constructing a 95% confidence interval. Okay, so as we mentioned before, N was 1,000. P hat we found was 0.662. And remember, we found that by doing 662 divided by 1,000. We're going to find our Q hat. And remember, to find Q hat, you're going to do 1 minus P hat, which is 1 minus 0.662. And that was going to give me 0.338. All right, so now we need to check to make sure that the N times P hat is greater than 5. So 1,000 times 0.662 is going to give me 662. And 1,000 times 0.338 is going to give me 338. So both of those are larger, which makes us happy. Boop. All right. So the next thing that we need to do is we need to find our confidence interval. All right. So the 95%, if you don't remember, that z-score is 1.96. So hopefully you remember that one, because that's a common one. We like that one. All right, so now we just need to find our error. So formula is, okay, so 1.96, P hat was 0.662, Q hat is 0.338, all divided by 1,000. And if you type all that into a calculator, you're going to get that your error is approximately 0.029. All right, so now all we have to do is P hat minus E and P hat plus E. So that's going to be 0.662 minus 0.029 and 0.662 plus 0.029 to give me 0.633 and 0.691. Okay, so now we can write our interval. 0.663 and 0.691. Okay, so our summarizing sentence for this is going to be, you know how I like to write these. With 95% confidence, you can say that the population proportion of all adults who say it's acceptable to check their personal email at work is between 63.3% and 69.1%. All right, let's do another one. Okay, so we have a survey of 498 US adults. 71% said that teenagers are more dangerous drivers. Construct a 99% confidence interval for the population proportion of US adults who think teenagers are more dangerous drivers. Okay, so let's see what we got going on here. All right, so they automatically gave me p hat. P hat is 0.71, which means 1 minus p hat is q hat. So 1 minus 0.71 is 0.29. Chloe, you're not going to be able to sit there, baby. It's my cat. All right. Okay, so where was I? P hat. Okay, so this is Q hat. N was 498. 99% confidence interval. Okay, so that Z-score that goes with 99% is going to be 2.58. Chloe. Okay. So let's go ahead and first make our check to make sure that these guys are bigger than 5. So 0.71 times 498 is 353.58, and 0.29 times 498 is 144.42. So yay, both of those are bigger. Okay. So now that we did that, let's go ahead and find our error. Okay, so 2.58, P hat was 0.71, Q hat was 0.29, divided by 498. All right, that is going to give me about 0.052. Okay, so next step, P hat plus that and P hat minus that. So plus we're gonna get 0.762, minus we're gonna get 0.658. So we're gonna write our confidence interval, remembering that the smaller number is always gonna go on the left, right? And then we're gonna write our sentence. So we can say, with 99% confidence, the population proportion of adults who think teenagers are more dangerous drivers. Oop, I spelled drivers wrong. Is between 65.8%, and 76.2%. Okay, so sometimes all right. Sometimes they're going to want you to find the sample size. And sometimes they will not give you your p hat and q hat. And if they don't give you that, you're going to use that p hat and q hat are 0.5. Okay. All right. So essentially what they've done, they rearranged the error formula that we were using before to solve for n. Okay, so let's just go ahead and do an example. You're running a political campaign and wish to estimate with 95% confidence the proportion of registered voters who will vote for your candidate. Your estimate must be accurate within 3% of the true population. Find the minimum sample size if no preliminary estimate is available. Okay, so we don't know p hat or q hat. We know our error is 3%, which we're going to turn that into a decimal, so 0.03. And the z-score that goes with 95% is 1.96. Okay, so let's go ahead and plug in. So n equals p hat q hat times z-score divided by error squared. So 0.5 times 0.5, 1.96 over 0.03 squared is going to give you 1067.1, which, remember, whenever we're doing this, you round up. Okay, even though 0.1 doesn't tell me to round up, you're rounding up, okay? Because we need the minimum sample that is going to give us a 95% confidence interval. So you always have to round up. Okay. All right, let's do one more like that. So in this example, very similar, we're running a political campaign and still 95% confident, error is still 3%, but they're giving us p hat is 0.31. Okay, so this is different in the sense that we can now find q hat. Okay, so p hat is 0.31, which means 1 minus p hat is 0.69, which that is my q hat. Okay, so let's write down our formula. N equals p hat, q hat, z-score divided by error squared. So p hat is 0.5, nope, I lied to you, 0.31 times 0.69, coffee hasn't fully kicked in yet, 1.96 over 0.03 squared, and that is going to give me 913.02, and again, we are rounding up, so 914. All right.